Hi, welcome back to Principles of Communications. In this video, we will be discussing about various types of radio receivers. There are two basic types of radio receivers. The first one is what we call the coherent receiver. With a coherent receiver, or what we call the synchronous receiver, the frequencies generated in the receiver and used for the modulation are synchronized to oscillator frequencies generated in the transmitter. That is, the receiver must have some means of recovering the carrier signal and then synchronizing to it. Next, we have the non-coherent receiver. With a non-coherent or asynchronous receiver, either no frequencies are generated in the receiver or the frequencies used for the modulation are completely independent from the transmitter's carrier frequency. Non-coherent detection is often called envelope detection because the information is recovered from the received waveform by detecting the shape of the modulated envelope. Moreover, the receivers described in this chapter are non-coherent. There are also various types of specific radio receivers, and the first one that we're going to discuss is what we call the TRF receiver, or the tuned radio frequency receiver. TRF receivers are one of the earliest types of AM receivers, and these are also probably the simplest ones that are still available today. This is the block diagram of a three-stage TRF receiver, which consists of the RF stage, detector stage, and the audio stage. Generally, TRF receivers require 2 to 3 RF amplifiers to amplify the signal to a usable level that can move the detector stage. The detector converts RF signals directly to information, and the audio stage amplifies the information signals to a usable level. And it has two inherent advantages. The first advantage that it has is it has an enhanced sensitivity, meaning that it covers a wider range of frequencies. And the second one is very obvious. It is evident that this circuitry is very simple. It just consists of three RF amplifiers, a detector, an audio, and then all the way to the speaker, which converts the signal into sound waves. However, it has three major disadvantages. The first one is that it has poor selectivity, and that it is somewhat unstable, and it also requires multi-stage tuning. Now, with the development of super heterodyne receiver, TRF receivers are seldom used except for special purpose single station receivers, and therefore do not warrant further discussion. The non-uniform selectivity of the TRF led to the development of super heterodyne receiver near the end of World War I. Although the quality of super heterodyne receiver has improved greatly since its original design, its basic configuration has not changed that much, and it is still used today for a wide variety of radio communication services. The super heterodyne receiver has remained in use because its gain, selectivity, and sensitivity characteristics are superior to those of other receiver configurations. Heterodyne means to mix two frequencies together in a nonlinear device, or to translate one frequency to another using nonlinear mixing. Here's a block diagram of a superheterodyne receiver. Essentially, there are 5 sections to a superheterodyne receiver: the RF section, the mixer or the converter section, the IF section or the intermediate frequency section, the audio section or the audio detector section, and then the audio amplifier section. In the next video, we will discuss the sections of a super heterodyne receiver, their functions and their advantages and disadvantages as well. Alright, thank you.